Okay, so here we're going to take a look at yet another application here, or another form of indeterminate that can be evaluated using L'Hopital's rule. So here we're going to take a look at infinity times infinity, minus infinity, excuse me, right, and see how we can manipulate it so that we can apply L'Hopital's rule. So let's take a look at, we're going to look at two examples here. So the first one being the limit as x goes to 0 of cotangent of x minus 1 over x. Okay. All right. So here we notice, right, as x goes to 0, right, then we have cotangent of x, remember, cosine over sine. So they're both, so it's going to infinity minus infinity. All right, so both of these are going towards, tending towards infinity. So what I'm going to do here is I'm going to combine it here. And the way I'm going to do that is we're going to go, all right, limit as x goes to 0. So this becomes cosine x over sine x minus 1 over x. All right, and then having a common denominator of x sine of x, that means that we have x cosine x minus sine x. All right. Now doing that, we see we get 0 over 0. So now it is of the 0 over 0 indeterminate type. And hence the L'Hopital's rule applies. So applying L'Hopital's rule here. Now again, what you're going to find out here is L'Hopital's rule is a good practice in applying all your differentiation formulas. So the top, right, we got product rule here, so cosine x minus x sine x. So that's the first one here, and then minus cosine x. And here we have another product rule, so we get sine x plus x cosine x. All right, and then here those in the numerator, the cosines cancel out, and we're left with the limit as x goes to 0 of negative x sine x over sine x plus x cosine x. Okay. All right, and again, notice here, as I plug in 0, then I still have an indeterminate type, 0 over 0. So I'm going to do this at least one more time here. So I'm going to apply L'Hopital's rule. So we get here negative sine x minus x cosine x. And then down here we'll have cosine x. And then here we'll have minus x sine x. And then plus x, well, excuse me, plus cosine x. Right, well, we use the product rule for x cosine x. Okay, and then here, right, cleaning this up a little bit, we get the limit as x goes to 0, a negative sine x minus x cosine x over 2 cosine x minus x sine x. And here, no longer indeterminate, we can really just plug in 0. So as I plug in 0, I get 0 minus 0 over 2 minus 0, which again is totally defined, right? I get 0 in the numerator, 2 in the denominator. That is totally fine. That quantity results in 0. Okay, and that's how you apply L'Hopital's rule for the infinity minus infinity. Let's do one that involves exponentials and see how that goes for us. So let's take a look at the limit as x goes to 0 on the right of 1 over x minus 1 over e to the x minus 1. All right, again, noticing as x approaches 0, right, both of these quantities are approaching infinity, right? 1 over a small number and 1 over a small number as well. So as it's written, it's of the type infinity minus infinity. So I'll start by combining these, the limit as x goes to 0 on the right, a common denominator of x, e to the x minus 1, and then up top, e to the x minus 1 minus x. Okay. All right, And from here, we'll apply L'Hopital's rule here. So here at the top, the limit as x goes to 0, e to the x, derivative of 1 is 0, derivative of x is 1. Here we'll use the product rule. So derivative of x is 1. We're left with e to the x minus 1. And then we leave x alone, and inside it's e to the x. All right. Now as I plug in 0 here, again, we're still at an indeterminate form. Right? When I plug in 0, I get 1 minus 1. Here I get 1 minus 1 plus 0, so all goes to 0. So I can do this again one more time. Right? The limit as x goes to 0 on the right. So the numerator is e to the x. Denominator, we get e to the x. Right? Derivative of 1 is 0. Product rule here, so plus e to the x plus x e to the x. All right, and now it looks like I can just plug in 0. So when I plug in 0, we get e to the 0, e to the 0, e to the 0 plus 0 times e to the 0. And all those e to the 0s are 1s, and then this quantity that goes to 0. So 1 plus 1, or 1/2. All right, and now we're able to evaluate this infinity minus infinity limit, right, by using L'Hopital's rule.